For an upcoming project, I need a linear motion system, some kind of linear bearing that can work vertically. And the constraints on it are pretty light, so relatively low loads, low speeds, low precision, low duty cycle. So I was wondering if I could get away with using this stuff. This is called Unistrut. I think it's so commonly used that it's even got its own kind of industrial standard, so it's not just made by Unistrut, the company. You can get sort of identical versions of it all over the place. And it's a kind of general purpose industrial meccano kind of thing. You can get all kinds of fasteners and nuts and things that grab onto the inside. And once you've noticed it, you'll see it everywhere. You know, if you're in B&Q or some sort of big warehouse shop like that and you look on the wall and there's a ventilation system or something, it's probably hanging off some of this. You see kind of network, cable, what's the word for that? Those kind of cable carrying thingamajigs. No, I'm blanking on this. Anyway, where you see cable hanging from the ceiling, quite often it's held on this stuff. So you see it absolutely everywhere. I wanted to know whether I could use this strut trolley system for my vertical axis for this upcoming project. So you can get, as well as all sorts of hangers and mounting accessories for this, there are some kind of motion components as well, including these trolleys. These are called strut trolleys. There are a few different kinds. This is the most heavily rated one. I can't remember the numbers off the top of my head, but depending on speed, I think it can take up to sort of 2 and a bit kilonewtons off the top of my head. So, but there isn't a huge amount of information on the internet. The pictures are pretty small. The specification documents are pretty thin, so I really couldn't establish whether it would do the job without just buying some and getting my hands on it. And spoiler alert, the answer is no. It does. It's not going to do what I want. And so I thought I'd share why, tell you why, and maybe help you make that decision without having to buy some, look at it, and send it back again. So, I'll just tell you what this thing is made of. So this is you can get various materials. You know, mild steel is obviously the default choice. I think you can get this in stainless, and galvanized or hot dip galvanized, depending on what you need. This thing, I think, is always the same. This is galvanized steel plate, about 6mm thick. Yep, 6mm thick. It's got just 4 ordinary metal shielded roller bearing races mounted on it, and they're mounted on roll pins actually, which is quite unusual. I don't know if you can see that on the video, but that's actually you can probably, if I get the angle right, you can see that that's a tube. That's a roll pin, which I don't think I've actually seen that before. Mounting a bearing on a roll pin. That's kind of sort of slightly gnarly, but also in a low precision application. Yeah, why not? Kind of a good idea, really. Excuse me. So, yeah, it's got 4 wheels, as you can see. They're 30mm outside diameter. They are 9mm thick, and they've got a 10mm ID. And yeah, like I say, they're metal shielded. So what I wanted to know when I ordered this stuff was how sloppy is it in the track. So applications wise, one of the main things you'll see these used for are sort of sliding doors. So if you're in a agricultural environment or something like a barn, it's the kind of thing you would see a door hanging from. So obviously this would be, well, let's do it. This would be up this way. And then a door could hang and slide up and down. And so in that kind of environment, the tolerances and demands on the system are pretty low in terms of precision, ultra low precision really. So yeah, this is about right. And I was wondering if I could get away with it for my application, but there are no specifications really that tell you what to expect. So I can tell you now that I've bought some, that in this axis, maybe I can show you with a little angle gauge here. If I stick an angle gauge on the side and just zero that, this angle gauge is particularly annoying. The number jumps around, but so that's about 0. And then if I put it on the trolley, that's about 0. And then I can skew it. So if I skew it that way, it's about 3.5 to 4 degrees. And then similarly in the other direction, about 3 degrees, 3.5 maybe. So yes, you've got about sort of 5 to 7 degrees of sort of included angle slop like that. And in this axis, sort of around the vertical axis of this thing, there's even more. There's about plus or minus 5 degrees, so sort of 10 degrees of included slop there. And then finally in this axis, I think it's the best axis. I'll put that so you can possibly see that there. And if I zero that again, so it's about 1 degree, maybe 2 degrees. So that's the best axis. There's about sort of 1 or 2, plus or minus 1 or 2 degrees in that axis. So yeah, that's what I wanted to show you really. And obviously it kind of makes sense because there are no elements on here that control slop in this direction. More advanced linear bearing systems are all about constraining all of the axes that you don't want to translate or skew and just leaving the one that you're interested in. And this system, I suppose it does kind of constrain them all, but not that well. So if you just measure in here, you can probably see there's quite a big gap between the edge of that bearing and the inside face of the Unistrut. Looks like about 4 mil, 5 mil even. Yeah, 4.8 mil just in that gap there. So obviously that accounts for that 5 degrees of slop. So obviously the system really doesn't have any way of controlling that that spacing. And of course these bearings aren't designed to have that outside face be used as a bearing surface. Of course, they're designed to roll, and that's it. So yeah, so I hope that that gives you a better sense of what the Unistrut P2950 carriage. I forgot to tell you that number. This is the P2950 unit and standard 41mm Unistrut. When you put those things together, I hope this gives you a pretty good idea of what that's like. All right, see you next time.